గోపి వస్తాడు వచ్చేది. Any answer, man? Hello?
Yes, sir.
We can do one thing. Total force exerted by sphere on cube, no? So we'll first see what are the forces on this. on the sphere, what are the forces? There is a contact here. First of all, it will be pressing or not, we should know. For that reason, what you will do? Find the acceleration of the sphere first. Acceleration of Q is rate of change of velocity. So that is 5 I cap plus 2 j cap. That means the sphere has two accelerations. One acceleration is along x and along y. So because this is inside, I am drawing the free body diagram of sphere with respect to cube. Cube has accelerating now. So whenever it is accelerating, there will be one force. What is that force called? This is the acceleration of the cube.
Pseudo force.
This is Ay. Therefore, there is a pseudo force here. Mass of the cube into Ay in opposite direction. Similarly, there is another force like this. Mass into Ax. Do you agree with this? Hello?
Yes, agreed, sir.
That means we can see that there is a weight here. Now, because this is applying a force on this, definitely there will be a pressing force on this. Any other force is there? This is N1. This bottom one also will be exerting. Understood this? Now here, what is the acceleration of the sphere with respect to Q? Acceleration of sphere with respect to Q is 0. Do you agree with this? He gave now. Hello.
Yes,
Yes.
sir. Cube is at rest with respect. Sphere is at
So
rest.
net force in x direction is mx. This is what is the net force here? This is m into acceleration of sphere with respect to q in x direction, that happens to be 0. Therefore, n1 equals 2ax. What is ax? 5. 10 Newton. Do you agree with this?
Yes, sir.
Sir,
Now,
one.
tell. You can ask.
Sir, why we are taking 2ax and 2ay? That
Where?
sir in free body diagram.
This is because it's ax.
2a.
Pseudo force will be m into minus ax. And what is pseudo force?
M into minus
Yes,
x.
sir. M into minus.
Minus means opposite direction.
Yes,
That is the
sir.
meaning, no?
Yes, sir.
Is it clear? So here, you are drawing the free body diagram with respect to sphere. So here acceleration should be with respect to FBD with respect to Q only, no?
Yes, sir.
Agreed. So here this is N2. This is nothing but AY is how much? 2. This is AX, this is AY, no? Plus 2 into 10. 24 Newton. That means, therefore, we can say that force on sphere exerted by Q is nothing but N1 I cap N2 J cap. N1 is nothing but 10I plus 24 J. Now you need net force, no? Great.
Agreed, sir.
Understood the method?
Yes, sir.
Started any assignment work?
Sir
Not yet.
started, sir.
How you are feeling? Easier,
Started,
difficult?
sir.
Easier, difficult?
Medium, sir.
Sir.
Mm. Spend some more time with physics, man. Once you learn that, you'll be happy. The entire engineering and enjoy. Shall I turn there? So remember that always net force.
Sir, in the Narayana material, there was a question, sir. I had a doubt in that.
I'll discuss it. Mass of body into
Sir, we have to find out force exerted by sphere on cube, no, sir. So it should be minus 26, no?
7. Tell what you want. What is asking? Mhm. So understood this? Magnitude of the force is same. Understood this?
Yes, sir.
Yes, sir.
Yes, sir.
It's clear?
Clear, sir.
First, that's what I said. Check up with respect to who you want to do the problem. Observer. After that, that fellow is an accelerating fellow, include pseudo forces. Otherwise, don't take pseudo forces. After that, choose the axis. These are all the forces in the directions. So mass of the net force in a particular direction with respect to a particular observer is mass of the body into acceleration of the body with respect to observer in that particular direction. Understood this?
Yes, sir.
Yes, sir.
Turn the page.
Minutes.
Return this.
Yes, sir. Complete. Yes, sir.
Now let us see the other aspect. That is, we have seen about normal reaction, mostly we concentrated. Let us go to the tension part. So there are three blocks like this. Okay, this is 4 kg. This is 2 kg. This is 1 kg. They are connected like this. There is a force of 28 newtons we are applying. Okay. Now you can see that we are supposed to find tension in each spring. How to find this? See, again the same story. First thing is,
Free body
this
diagram.
whole system is accelerating. Agreed. That means all these things must have same acceleration, no? So this is string 1, say string 2. There is only one force here. This is T1. Okay, this is T1. This is string T2. This is T2. Do you agree with this? Now all are having the same acceleration. Do you agree? I don't need weight because along X I am showing. See, if nothing is mentioned, it is nothing but a free body diagram with respect to ground only. Followed. So with respect to ground, it is understood that sigma fx equals max. So this is only force is 4a. For the next one, what you have T2 minus T1 equals 2a, second block. For the third block is 1 into a. How many equations are there? 3 equations, no? Agreed? Now can you
Yes,
solve
sir.
this equation? T1, T2, a 3 equations, 3 unknown. Simultaneous equation, can you solve or not? Or shall I solve?
No, sir.
Yes, sir, we can do.
Substitute here, you will get T2, that is substitute here, you will get A. Once you get A, problem is solved, no?
Yes, sir. Sir, one doubt, sir.
Tell
Sir,
me.
sir, every block has same acceleration. I didn't understand that part, sir. Can you please?
No, when you are pulling this, see this is one string, man. These are the two parts, no?
Yes, sir.
See, you are the observer here. Okay. Now this is one part, point 1A, this is point B. Okay, this is nothing but being pulled like this. Okay, this is XA, this is XB. Now you can see that if this B moves by some distance, then observe carefully, this is suppose XB from some S or some X something. This must also move. Now see, if X2 is more than X1, string breaks, no? Because we consider which strings for the timing inextensible strings.
Sir.
Now if X1 is more than X2, then what happens? String will become what? Slack. Slack means no tension. Loose we call, no?
Yes, sir.
Understood this clearly?
Misunderstood, sir. Understood.
Now if therefore if X1 equals X2 only, string is taut. Taut means under tension. Understood what I am saying?
Understood, sir.
That means both ends have same displacements, no? In the same interval of time.
Yes, sir.
Therefore, what you have dx1 by dt must be equal to dx because x1 should be equal to x2. This implies v1 equals v2. Again, differentiate this. This is nothing but a1 equals.
One equals to
Understood
Yes, sir.
this?
Understood, sir. Understood.
See, your understanding for everything as a reason is there. For everything, whatever you do, there is only science. When you do learn something without reason, that is called history, not science. Ashoka was born on so and so date. Why he was not born earlier means there is no answer for that. That is history.
Yes, sir.
Understood this?
Understood, sir.
To learn anything, learn every subject by reasoning. Don't simply mug up that. Is it visible, all this?
Visible, sir. Visible.
Yes,
Yes,
sir.
sir.
Now you can solve this. So all points of the string must have same velocity. That means same speed and direction for the strings to be taut. Okay. So this point and this point has same acceleration. Agreed or not?
Yes, sir. Agreed.
What accelerations and tensions?
Yes, sir.
Sir,
Yes, sir.
tension and force are equal. Same. Tension and force are same, sir.
Tension and force are same. Where are you taking?
No, sir, I'm just asking. And
Tension is also a force.
a type of force, no, sir.
Yeah. Gravitational force, tension force. Normally, I gave now what are the forces possible.
Sir, I am not understanding your question, sir. Can you please explain it?
Which question, man?
2 minutes, sir. I will, sir. Sir, it is a flexible chain of length L and mass M is vertically suspended with its lower end just touching the table. If it is released so that each link strikes the table and comes to rest, what force the chain will exert on the table at the moment y part of lengths fall on the table?
What is it? I'll come back to this. What is tensions? Got any answers? Did not solve?
Yes,
Yes,
sir.
sir.
Solved.
Acceleration is equal to 4.
For T1 16,
T1
T2
16,
24.
T2
24, sir.
Yes, sir.
Acceleration is for T1,
T1 16 Newton,
T2.
24 Newton.
Now, shall I turn this? Hello.
Yes,
Yes,
sir.
sir.
See, the same thing you can do the other way also. Simply regard all the three blocks as one system. Then you'll get acceleration easily. See, when you regard the whole three blocks, all the three blocks as one system, this is one system. You are applying a force of 28 newtons. This is 4 kg. This is 2 kg. This is 1 kg. Now this whole thing, three blocks. You have sigma fx equals max implies only force is this the total mass of the system into acceleration. So what is acceleration? Agreed. So you can get the acceleration. But if for again to get tensions, you must use what? Free body diagram of each block. Understood this?
Yes, sir.
You can only find the acceleration of the system. But again, you have to take this. This is T1. Okay. Similarly, if you want, you can take this also. 2 kgs, T2, T1, acceleration. What this? Same thing your previously also, no? Hello?
Yes, sir.
Return this.
Yes, sir.
Sir, 1 minute.
1 minute, sir, 1 minute.
Right.
1 minute, sir, 1 minute.
See here. Pardon? Hello?
The previous page.
Finished?
Yes.
See here, generally, what is the meaning of this? Remember?
Yes, sir.
Then what is say rope is inextensible means? What is the meaning? Tension. Just defer that already I gave.
Frictionless.
What is it? Inextensible, what will have?
Acceleration will be safe or inexchangeable.
Tension will be there.
Understood this? Remember?
Yes, sir.
Note on this. Finished? Understood this?
Yes, sir.
Return this.
Yes, sir.
So here they say, so it is understood for the time being, all these are true, unless specifically mentioned. Okay. Understood this?
Yes, sir.
Put it down.
Sir, one doubt, sir.
Now tell me.
Sir, if string's mass is given, means what we can do, sir?
That will
Related to
that will tell you. Wait, that one will.
yes, yes,
Next
sir.
is
Yes, sir.
that.
Okay.
Return this.
Yes, sir.
Yes, sir.
Suppose we have a situation, a pulley on which we have two masses hanging like this. We have to find understood this. See here,
Sir.
you agree with this?
Yes, sir.
Only we are just assuming, it need not be true. This is an assumption. Okay. Okay, we'll assume. Okay, so here tension is same now. This is T. Do you agree with this?
Yes, sir.
Do you agree with this? Right. Now apply for this. If you apply T minus M1G equals M1A, no? For this block, agreed. We'll
Agree,
get
sir.
tension and acceleration. Net force in the direction of acceleration is mass into that acceleration in that direction. Understood this?
Yes, sir.
Here M2G is in the direction of here, so I'll take that as positive. This is opposite to A. Here T is in the direction of here, therefore I'll take this. This is opposite to A, I have taken negative. Understood this?
Yes, sir.
Yes, sir.
See how much you are getting this.
Sir, what if we assume that M2 is moving upwards and M1 is moving
You
downwards?
can assume in any way. After solving, suppose A happens to be negative. That means opposite to our assumption. Nothing else.
Yes,
Okay?
sir. Yes, sir.
I told you very clearly, you can assume in any way. After
If
solving,
it comes in negative, then it is moving in the
opposite
opposite
to our
direction.
assumption.
Yes, sir. Sir, how did we get tension as 2 into M1 M2 divided by M1 placement 2 into G?
Pardon? Pardon?
No, sir, I didn't understand how did we get that 2 M1 M2 divided by M1 placement
Solve
2?
this, man. Solve this.
I have to
You can't
solve
solve,
it.
no? After
Yes, sir.
solving only, you'll get this, man.
Yes, sir. Yes. After solving, you should substitute the value of A.
Yeah. Shall
Got,
I
Yes,
solve?
sir. Yes, sir. We can solve. We can
got,
solve.
sir. Solved.
You did not get, huh?
Solved, sir. Got.
You got on it. See. You know how to solve two equations, no?
Yes, sir. Yes, sir.
Shall I turn this? Hello.
Yes, sir.
Minutes, sir.
1 minute, sir.
See, this is usually called as Atwood machine. Don't think Atwood machine is something else. The oldest mechanical device to lift masses is this one. Atwood machine means basically followed this. Hello.
Follow, sir. Follow, sir.
Yes, sir.
Shall I turn this?
Yes, sir.
Yes, sir.
See, you can as well do many problems by simple shorter method. This you are taking the acceleration. What is it you are taking down? This is what you are taking. No? Now we'll take what is the unbalanced force? Can you tell? M2G is more than M1. That's why it goes no. What is this called? Unbalanced force or not?
It's
Yes,
the
sir.
balance.
Okay. So we have acceleration is nothing but net unbalanced force by so here what you have do you agree with this?
Yes, sir.
Understood this? Directly can get this.
Yes, sir.
Suppose you are having here what is the unbalanced force?
M1G and
M2G minus M1.
No, no, M2G is balanced
M1G,
here.
M1G, sir. M1G
M1G
minus.
Only M1G only because M2G is balanced by normal reaction. This is pull due to tension, no?
Yes, sir.
Agreed. So here, unbalanced force is the net pulling force, man. Remember that
M1G, sir.
unbalanced force okay. So here, what is unbalanced force?
M1G.
Hmm.
Sir, normal force is also come now, sir. Normal force of M2.
That normal force M2 is the block moving like this, man. Use some sense, man. This normal
Sir,
is the
N,
MG
sir,
square.
N2.
Huh? This one, N2 upward, M2 downward, M2G downward. There is no motion in this direction, no?
Yes, sir, yes, sir.
Do you agree with this? Therefore,
Yes,
this
sir.
acceleration, understood this?
Yes, sir. Sir, one doubt, sir. Sir, how we will find tension in this string, sir? Can you
Pardon?
please? Sir, how we will find the tension in that string? First
Okay, now
example.
you understood the acceleration. Now
Yes, sir, acceleration.
that
Understood.
part is over now. Now for finding tension, draw the free body diagram. What is it in the T?
T. Same.
That's all. What is it in it?
Understood. Okay.
Understood this?
Yes, sir. Understood, sir.
Shall I proceed?
Sir, tension will not act along M1, sir.
Like here I am showing, no?
Sir, then we should take it as minus here. For you wrote
No,
tension is equal to
man.
M2 N, sir.
For this man, only force pulling in the direction of acceleration. What is the only force? T.
Tension T.
For this, you have two things.
Tension and
See
M1G.
here, this M2G is a normal here. There is no acceleration this
Yes,
way.
sir. Yes,
Acceleration is this side. So what you have? Again, you'll get the same thing. Solve it.
sir. Yes, sir.
You'll get same value. Net force in the direction of acceleration is mass into acceleration. Till your death, you'll be using this only. To finish your job, engineering job, you attain 100 years, grandfather, everything. But rules are same. Understood this?
Yes, sir.
Yes, sir. One
Now
minute.
let us see. Not completed.
Answer.
No, some boy asked. Completed? See?
Yes, sir.
See here, suppose you want to know the net pulling force. This is mg, no?
Yes, sir. M1G.
This is what, can you tell? There will be
M,
two accelerations. What are those? Down the plane, what do you have?
M2G centimeter. M2G
Remember
cos
this
theta.
or not?
Yes, sir.
Yes, sir.
We always remember for an inclined plane, any particle is here. This is mg, this is theta, this is 90. What is this? 90 minus theta. Okay. Now down the plane, this is mg cos 90 minus theta. That is only what?
MG
mg
centimeter.
sin theta. Perpendicular to that, you have sin 90 minus theta. What is this? mg
MG
cos
cos
theta.
theta.
Understood this? Now you can see what is the net pulling force on this. Is nothing but m1g
M1G,
minus m2g sin
M2G
theta
sin
now
theta. Yes, sir.
by,
M1 plus M2G sin theta.
so acceleration is nothing but mass of the system, no? Any doubt is
Yes,
there
sir.
here?
No doubt, sir.
Understood this? Now suppose you want to know the tension in this. The same thing. This is tension is same. This is T, this is T. You can use any of this. I'm assuming this is going this. You can take M1G minus T equals M1A. You can get, substitute this. Okay, this is, you can take this here also. T minus,
M2G sin theta.
now also you'll get the same result. Understood this?
Yes, sir. Sir, you are taking angle along vertical, right?
Angle and vertical.
That upward, sir, upward diagram.
This one.
Yes, sir, yes.
What do you want?
Oh, sir, just asking, sir, we are taking along vertical now, sir, that, for that.
This is MG, man.
Yes, sir.
It has two components, along the plane, perpendicular to the plane. This is
Yes, sir, yes,
inclined
sir.
plane theta, this is 90. So in this triangle, this is 90 minus mg acts vertically down only, no? Not that I am taking. No?
Yes, sir. Yes, sir.
Any doubts are there till here?
No, sir.
Yes, sir. One doubt, sir. Sir, this M1G and M2G sin theta, they are not in same direction, sir. Means
Which one?
M2G. So this
M2G?
M2G, yes, sir. It is in different directions, sir.
Which one?
So this M1G and M2G sin theta.
Uh, That's what. This is trying to pull, but that is opposing, no?
Yes,
The
sir.
net pulling force will be the difference, no?
Okay, sir. Okay, sir.
This is M1G, man. This is M2G. So what is the net pulling force?
Difference. It will be difference. Yes, sir. Understood, sir.
Suppose you don't want to do, draw the free body diagrams as before and solve that even for acceleration. This is easier, no?
Sir.
Acceleration directly you can find. Tell.
Yes, sir. Sir, but in the previous case, we took only M1G, like it is in the horizontal surface.
What is the pulling force here, man? Any opposition is there
M1G.
for this? Any opposition is there for
No,
this?
sir.
That's why I did not take.
No.
Here there is an opposing force, no?
M1, M2G scientist.
Here also this is opposing force here. This is coming like this is opposing. That's why I subtracted.
Sir. Yes, sir.
Opposing force should be taken now. Understood this?
Yes, sir.
Understood, sir.
Right, go through this. Don't worry. Again tomorrow I'll discuss. Okay? Right then. Take care. Bye.
Thank you, sir. Bye.
Bye.
Thank you,
Bye.
sir.
Bye. Bye.
Bye, sir.
Thank you, sir. Bye, sir.
Bye. Bye.
Sir, we have ends class today, na?